The broadcast is now starting. All attendees are in listen-only mode.
Well, hello everybody, and welcome to Coffee with Caleffi. Oh my gosh, November, mid-November, where did the year go? I want to thank everybody for attending today, and of course, thank you for the Caleffi support. Hydronics, most of the PowerPoint presentations I put together, my training that I do out in the field, a lot of that material gets generated via the Hydronics issues that we have out. Hopefully everybody's getting those. We're on issue number 17. Great one coming up next, number 18. I'm really excited about that. And again, it's another one that was by popular request. We're going to be talking about fluid quality in systems and what you need to know, what you can do about it, and stuff like that. I think you're going to really enjoy that one. So we're hard at work on that. Then again, as a staff effort, so I think you're going to find that pretty useful. All right, so this is what I'm going to do today. I want to kind of just sum up all the pieces. So this here, what you're seeing on the screen right now, is actually countermeasures that we offer to some of our suppliers and of course contractors, anybody that wants one. It's just something, it's a two-sided piece, and it just kind of goes through and shows pretty much all of our components and where they get put in the system and how they get used. Obviously there's a lot of different ways the components can be used, but I want to try and go through them piece by piece and section by section and just kind of show you, why you would select one over the other, what's the pros and cons, excuse me, the different types of devices that we offer, what a combination of devices bring to the table and stuff like that. I don't know that I'm going to get through every single component that we have on here. We've got a pretty a big offering. What I will do is, get through as many as I can in the hour. I've got 4 hours worth of material as usual when I try and get to you. But I do have a part 2 to this next month, so the ones that I miss and say, gosh, you forgot to talk about this or that, let me know. I think I've got them queued up in one of the 2 presentations. Next month I kind of wanted to focus a little bit more on renewable energy. Obviously a lot of the products cross over from hydronics to renewable and stuff like that, so I felt the ones that I missed or didn't have time to get to, I'll certainly get to next month. So with that in mind, what I thought we'd do is start kind of like in the boiler room. I mean, that's where most of the energy gets transitioned from our fuel source into our piping and stuff like that. So I'll start talking about components in that area, and then we'll kind of branch out across this mat. I'll bring this mat up from time to time just to kind of show you where I'm at and kind of the flow that I had in mind. This is the pump that I have on my system. I know a lot of you guys are interested in variable speed pumping, and I came up with a fairly efficient, maybe not prettiest way to do that. So if you're struggling with variable speed pumping, you want to try before you buy. Honestly, I don't know where that came from. It was sent to me by another person, probably that thereifixedit.com website or something like that. But all right, so there's a couple key components to every installation, and this applies whether you're doing a brand new job, you're just designing a job, maybe putting a bid together, a remodel, a replacement, a retrofit, or something like that. There are a few key parts of the puzzle that you want to make sure you do, and a lot of that revolves around knowing what the load is, the load calculation. We want to look at the heating load and the domestic water load. If we're going to use our boiler or our system to generate both, we got to know what both those numbers are. We don't want to just be throwing darts at a wall or just guesstimating stuff. There is easy ways to do that now. There's programs available, some of them for free online, that can help you come up with those numbers. The same applies to solar. We want to come up with a solar fraction. What percentage of the load can we cover with a solar collector on the roof? And other data as far as documenting the jobs when we're done and stuff like that. All that really should be part of every installation. Where I always start, regardless if it's just like I say, a remodel, replacement, or a new job, is with the load calculations. There's various programs out there. You might have something you're familiar with. Most of the radiant manufacturers offer programs, typically for free, or can help you with loads like that. I like this program right here. I've used this since it came out. It's a very simple, non-generic load calculation program. You can see over here on the right, it doesn't take a lot of data input to really give you, this is the number, this is what we're going to talk about all day today, how we're going to move that amount of energy into this room or this space or something like that. This allows you to play with different design conditions, outdoor conditions, indoor conditions. Typically, you'll put design for your area. A lot of information, weather information available online. I think Jody talked about some of that in the last presentation. We can go to NOAA websites and stuff like that and get hours of occurrence and different weather information and really get a tight number. But don't ignore this important step. I know a lot of guys just say, well, I do that house in that neighborhood all the time. I'm just going to wing it. Things change in buildings over the years that would change that number, sometimes considerably, if upgrades have been made. So make sure you do that first step. Now the heat source, we're not in that business, but how do I decide what's right for me? It could be based on what your energy costs are. I know natural gas is being run out to a lot of areas where you, in the past, only had maybe electricity or oil. I was just up in Alaska last week, 2 weeks ago now, I guess, and natural gas was going out a lot to the villages there. So people that were kind of tied into oil or wood fires for all these years now have more choices. So take a look at what's available. You can crunch numbers on that also. You can compare the cost of operation for different types of fuel sources. There's calculators online. I think the DOE, Department of Energy, has a really good freebie calculator if you want to say, well, this is what I'm paying for gas or oil or LP or what my wood costs are, and you can compare it. And there's other different inputs. It could be a cogen unit, where you run the generator to provide power and pulling heat off of that, or a combination of those. Multi-fueled systems, we're using some sort of combination of all these things. We've got to bring them all together. We've got to make sure they all get along with one another for pumping requirements and everything else. So then the next step is, how are we going to get the heat to the space, to the room? What type of heat emitters are we considering? Are they low temperature devices? Are we going to connect those to a high temperature boiler? If so, you're going to want to look at one of our mixing devices. We'll get through some of those today. You can mix and match systems. In fact, January, Jody's presentation will be talking about how you can come up with multiple temperature supplies off of one system. Sometimes you'll have a high temperature, maybe a coil or something like that, and then in a fan unit, and then you'll have some radiant. So how do I mix multiple temperatures? We'll talk on the whole webinar that Jody will do will be addressing that. And again, panel radios, common in Europe. We're seeing more and more of those here. I would consider that maybe a mid-temperature heat emitter, not as hot as typically a fin tube would want to operate, typically not as low as a radiant, but somewhere in the middle. So we want to bring all those together in a system. If you don't have something you like, I thought I'd throw these in for fun. These are some of the radios I've made over the years. These are typically my Christmas present for my wife. My son and I will put something together. So, really anything that you can flow water through, it could be a microbus here, Jerry Garcia type of spin on that, or a towel bar that you made. I made that with a cordless drill and a hacksaw years ago, and just had a welder put it together for me, or, cast a concrete dog and put some tubing inside the dog. These are all low temperature emitters. I'm running these about 120 degrees. A Caleffi thermostatic valve. I reach out of bed here in the morning, reach over, crank that up. This is a low mass heat emitter, so within seconds of me turning that dial up to a higher number, I stand in front of that. It's like the sun shining on me. So get creative. It's fun sometimes to think outside of the box for heat emitters. Additional resources, probably the Bible of our industry is the modern hydronic heating. It's on the 3rd edition right now. That steps you through, from the heat load calculation all the way down to a good design. Probably none better than the Caleffi Hydronics journal. I showed you that on one of the first slides. We're building on that library all the time. With the fundamentals and some of the issues that we've already got out there, you can get a pretty good understanding if you're a technical person, read through that library, and by the end of it, you'll be pretty up to speed on what's doable and how it works. The Radiant Panel Association out there cranking out good material and training, certainly different manufacturers' manuals. There are some other online sources for courses that you might want to take. All right, so back to the motor. I try and put some slides of some of the Caleffi excellence that have been sent to us over the years. This one is, I think, a great, example of what we should all strive for as far as the, the look of that job, all the components that you need to make sure everything gets along in here. This is a multiple boiler application, so these boilers can stage in, they can modulate and stuff like that. So what we're allowing to happen here by using this hydro separator is making sure that as these boilers ramp up and down or kick in on and off or stage in and out, that we're going to get good flow through them. We're going to pump them just properly, and then of course we're going to go down with the that temperature directly to the slab from the condensing boilers. There's no mixing device in here because the boiler can modulate and can handle the temperature that comes back from this radiant floor installation. Thanks for that nice job, by the way. Priorities, this is what we need to have in every system. We've got to make sure if we're selling our customers high efficiency equipment that we're going to install it in a way with the right components in the right place that we provide that efficiency. If you're selling 90 plus efficient boiler and you're putting it in with the wrong devices, or you're not getting the air or the dirt or the debris out of that, you're not in fact getting that efficiency that you promised or that you sold the person. So I would say those are probably the key and the most important on the boiler installation is the air, dirt, and possibly magnetic separation. Things have changed the way the boilers are made. We've got to really pay attention to that. We've got to make sure that we've got good transfer between the flame, the 800-degree flame inside that heat exchanger, and the fluid that's circulating around through your system. And typically that's what we're seeing is boilers have shrunk over the years, lower fluid capacity, low mass boilers, real thin heat exchangers. We don't have as much wiggle room as we did with the old cast iron boilers where we had possibly a 1/4 inch thick of metal casting there to give us a little forgiveness and stuff like that as far as abusing that heat exchanger. We'll talk about the central air purgers. Every system should have an air purger at the equipment. And this, I keep saying heating. This would apply for a heat pump also. We'll talk probably more about that in the next month thing. I consider that more of a renewable energy. Dirt protection, magnetic protection, possibly a flow switch, to drop out the boiler if there's a condition where we don't have flow going through the system. Thanks to Nathan for this nice picture, by the way, up in Alaska. I got a chance to meet with him last week. Here's probably a fairly common example that you guys see out there on existing buildings, where we had a cast iron boiler, copper tube boiler, and fin tube. This is a really good example of the key components that go right at the boiler that we wanted. Now, we don't have an offering for pressure relief valves. I'm not ignoring that in my offering or my spiel here. That typically is supplied with the boiler. That's something that protects against the high pressure conditions. But I want to talk about all the pieces once we start leaving this heat exchanger as it is. And right here you'll see an air separator, an expansion tank, fill valve, purge valve on the back side of it. What happens on a system is we heat water, the first time we put the water in there, there's some air in there, there's some dissolved air in there, there's some big bubbles. We'll purge those out, and then we want a device that'll keep working, after we leave, and it'll grab little bubbles that we can't get out on the initial purge for whatever reason. And that's why we want to have this device right at the boiler. At the hottest point in the system and also at the lowest pressure point is the best place to get air out of a system. That's the best, lowest solubility, and that's why we show with the circulator pumping away from this and the air removal device here, we've got that high temperature, we've got that low pressure area that'll help us get that out there. That's also an ideal place to add a fill valve. A lot of times the guys will just tee it right into the system here. Fill valves, what we offer there, what the fill valve does for us in the system is that puts the initial pressure in the system, what we call the static fill pressure, and that pressure would be decided by, how high you have to lift the water up in the building over the level where you're filling it. So if you've got a boiler and you've got 1 or 2 stories above that boiler that you have to lift the water up to, that's what the fill valve is going to do. We've got kits that would include both the expansion tank, the fill valve, and the air purger. That makes it even simpler, so you've got all the solutions in one box. I want to talk about the offerings there. So we offer this with or without a backflow preventer here on our autofill valve. What we've added this year, maybe some of you haven't realized, we have this gauge option now. It's a nice quality gauge, and so what this allows you to do is check and confirm the pressure going in the boiler. If you don't have or don't trust the gauge that maybe came with the boiler, this is going to give you an indication of what you filled the system to, dial in the pressure you want here. This is a high flow valve. There's no need to bypass this valve and have a workaround. When you start this valve up, the first time flowing through it, as long as you have 30 pounds inlet pressure coming in from your city or your well pressure here in your building, you're going to get about a 5.5 gallon per minute flow going through this device. And that's typically enough to purge most residential systems. Sometimes you have to break them down into pieces if you've got a lot of big piping, but that's what we're offering here, is something that will fill the system quickly. It's got a pressure gauge on so you can monitor for leaks in the system, fill it up, shut off the valve or shut off an isolation valve here, keep an eye on your gauge for a couple hours or a day. It'll be a troubleshooting device as well as an indication that you've filled your system to the proper pressure. Over here we're showing a similar valve here. This is a 3/4 version, so a little bit higher flow rate. We'll get about 8 gallons per minute through this device with a velocity of about 4 feet per second. Same dial up here that you can dial in and adjust the pressure on it, the gauge again to confirm it and stuff like that. Unique about this one, going back to this for a second, it does go up to 60 psi. A lot of the other brands that you might find out there typically will end at 30 or 45 pound pressure. So if you have an application where you need the higher fill pressure, it's built right into that valve. I kind of consider that process, that filling and purging, a 3-step process. We fill it, which means we get it up to the static fill pressure that we need to lift the water up into the system. Then we purge it. We hook a hose somewhere on a valve, and we allow the air bubbles to be forced out as the water's filling the system. That makes sure when we start up our pumps that we're going to get circulation through the system. The third part that sometimes gets overlooked is what I call the flush portion of the fill and purge. And with the flush, how that differs from the purge is I want a little bit more velocity. And an example here, here's a boiler that somebody's taken out of a job, and you can see they've laid it outside, dumped out that debris that's in it. Filling and purging a system doesn't necessarily move this type of particle out. In order to move heavy debris like this, sediment, dirt, solder balls or whatever might have settled down to the bottom, we need to have a pretty good velocity. We want to have about 5 feet per second or more velocity to flush that out. So the valve that you put in needs to be able to produce that amount of flow, or you're not going to be able to scrub any of this heavy metal out. How much flow do you need? Well, it depends on what pipes that you're trying to flush and purge through. And there's calculators. This is just one I pulled off a free online site here, that you can determine what the velocity is through a section of pipe. Here's an example. I put in 1-inch pipe ID, so that would typically be 1-inch copper, would have a 1-inch ID. At 13 gallon minute flow going through that, I'll get about 5 feet per second, and that's what I need to have to be able to scrub this type of debris out of a system, whether it's a new system for the first time or you're retrofitting an old iron pipe system. You might have some of this debris in there that you need to flush out. So just make sure that the valve that you're filling with has the ability to do that if you're concerned about flushing this type of material out, because 5 gallon minute flow right through a fill valve, sometimes you might need to bypass that. This really hit home for me a couple years ago. We had a booth at the IGSPA ground source heat pump show down in Tulsa, and I was walking around just checking the other booths, getting to know people and meet people, and I came across this company here called Purge, right? And I said, well, what do you guys do? I mean, why are you at this show? What do you have to offer? They said, well, we go around and purge out problematic systems. And it could be a new system just starting up, or it could be a system that has had issues over the years. And I said, well, what's unique, to what you do or how you do? And he said, well, we have these, portable devices that we take around, a lot of different sizes. You can see some of them. And what we do is we'll go and we assure with ultrasonic flow meters on the piping that we get up to 5 to 6 feet per second velocity, and that allows us to shove stuff like you see in this picture here, which actually came out of a system that had been in there since the looper had put that field in, and he didn't have the ability to move that amount of flow through it to scrub that out. So if you get into a job like that, you might need a pump card or something like that to give you the additional flow that you can't get through a fill valve. We do offer one of those. Caleffi, we've got a little 1/2 horsepower fill and purge cart that can sometimes help you, and sometimes you need to call in the big boys like this here. They can purge up to a 48-inch pipe size with this equipment here that they put together. So make sure that you're getting that debris out, that you're purging it. Other important numbers that we wanted to monitor, I kind of showed you the pressure gauge earlier. We do have temperature gauges that are available that go on some of our devices. We offer a tailpiece that can be added on to like our mixing valves. We offer the QuickSetter Plus that has a temperature gauge. This allows us to adjust flow rates based on temperature. So if we're trying to arrive at a certain delta T or something like that, now we've got the ability to read that temperature. We do make a combination gauge, pressure and sometimes called a PT for pressure and temperature gauge here. We offer that can read pressure and temperature. The other important step is sizing the components properly. And here, this is probably a classic example, I think, of where systems can kind of get off track a little bit, is when we start looking at different devices that we want to put in there to mix temperature down. I know Jody will talk about this more. And this is one I think probably gets misapplied a lot of times. And this is a thermostatic mixing valve, our 521 series. This valve could be used on domestic water, or it's commonly used as a mixing valve to mix down the lower temperature off a high temperature boiler. This valve has a flow rate of CV factor of a CSV of 3.0, so that's 3 gallons a minute can move through this valve with a 1 pressure drop. So in the box or on our website, we'll have a sheet like this, a tech sheet, and this kind of shows the performance curve of that valve under different flow conditions. So go down here to the bottom axis, for example, and it's written in English units as well as metric units, so we'll go to gallons per minute, and let's say 3 gallons per minute. If we run up that line, where that 3 gallon minute crosses our performance curve there, that'll show us that 1 pound pressure drop through that valve. This curve, by the way, is sometimes referred to as a hockey stick, the shape of that. I think this animates in a little bit. So you can see at the 3 gallon per minute flow rate, we've got a 1 pressure drop. So you say, well, I want to use this on a domestic water application, and they've got a body spray in their shower, and they need, I don't know, let's say 8 gallons a minute or 7 gallons a minute. They need a higher flow rate than what the valve says on the label of the box. What's going to happen? So here we are, 3 gallons a minute, 1 pound pressure drop. Now let's say we're piping this with 3/4 copper pipe, and now we want to look at an example with a higher flow rate. Again, let's apply that body spray. So let's go out here, this flow rate. I got to move my box out of the way, I can't read my. And then we run that flow rate up to the performance line, and now we can see that valve flowing that kind of flow rate is going to have a 7-pound pressure drop. Now that may or may not be a problem with the system. If you've got a customer that's got low pressure coming into their house, let's say they've got a well that only supplies 30 pounds pressure, and you're going to take a 7-pound pressure drop through this valve at that kind of flow rate, that might not be acceptable to the homeowner. They say, where did all my pressure go? And you can hardly take a shower anymore. The other thing that you have to be concerned about is the flow rate going through the pipe that you're going to connect this. So if we've got 3/4 copper pipe, we want to stay under that 4 or 5 feet per second velocity going through that. So the limitation is not just the flow rate through the valve, but also the piping that you connect to it. So you can see as you go out on the hockey stick up towards, I guess, the handle of the stick, if you were, the higher up we go on these flow rates, the more pressure drop. There's going to be a point that if you've got to use a pump on this valve to move it through a radiant system, for example, the pump that you apply needs to be able to overcome this pressure drop and all the other pressure drop in that circuit. So you add these numbers up and you might find that you don't have enough pump to get the job done. And that's, I think, what happens oftentimes is those get over applied. They say, you know, I'm just not getting enough heat out to my circuit. And we do have an easy solution for that. We do have high flow mixing valves. I'll show you some of those that are specifically for you know, jobs where you need flow rates to handle a larger radiant zone, and even on our domestic water mixing valves, you know, for higher flow rate. And this is one of the things that can happen when you've got excessive velocity in piping. You know, if we've used a piece of 3/4 pipe and we're running real high velocity through that, you'll actually start eroding the pipe. It's almost like somebody's taken an ice pick in here and chopped away at the copper. That's called corrosion erosion, and it can be caused by high velocity. The temperature of the water plays a part in this also. The hotter the water becomes, the more aggressive it can become. So that's why it's important to size the components for the flow rate, for the job that you're trying to do. We've got charts, we've got tables, we can help you with that. If you need help, just call us, and we'll give you some help on make sure you get the component size properly. All right, air separation. This is a biggie for me. This is something that for years, you know, we had just a device that had a ramp or a scoop in it, and it would just try and, you know, scoop the air out of the flow as it went through it. It did an okay job, but we need to do better than that now. We need to get little, what we call micro bubbles. In the bottom of this picture here, these are bubbles that might not even be visual to the human eye. It might appear as cloudy water when you fill a glass. That's tiny micro bubbles. It's really hard to have those just come out of an air vent without some sort of a, I don't know, let's say encouragement. So what we do is we put a media in there. We call it a coalescing media. I sometimes call it a collision media, because what we're doing now is we're bringing the flow through that media in there, and it drives these little bubbles. These little bubbles will cling to the sharp surfaces on this media. The little bubbles rise up, float in the bigger bubbles, and eventually they can come out the vent in the top. This is important because we want the best heat transfer. We got to get these little bubbles that might be coating out our heat exchanger. We need to get them out of the system. It's going to be important to make sure that it's quiet. We don't want to hear bubbles gurgling through our you know, heat emitters at night when we're trying to sleep. We want to make sure that we've reduced the potential for, you know, corrosion problems. Air in the water can cause additional corrosion problems. And of course, we want to protect our circulators. They move water, not air. So we want to make sure we get the air bubbles out. One of the keys to making this efficient is having a chamber in here that can allow the velocity as it comes in here to slow down. It's called a low pressure zone. So the larger that you make this, you know, this area in here, as the flow comes in here at, let's say, 4 feet per second, it sees this kind of wide spot in the road, if I could say that. The velocity will slow down for a minute. It gives this median here a little bit extra help to work if we can just slow that velocity down and grab that air as it goes through there. This is our brass version here. We do make that in you know, welded steel versions. At 2-inch pipe size, we go over to a flange version. We've added a float in here with a pin in it, so if you put this in and it's a little crooked or something like that, the float is riding up and down on the pin. It won't rub. You can see there's a tight tolerance between the float and the sidewall of that, the upper part of the air separator. So what we do here is by pinning the float, it can never get rub against the side where it won't float up or won't float down, and it's not going to work properly. This device here, we put a little gooseneck fitting, I call it here, with a ball valve, a hose connection on it. That allows you, as you're filling the job for the first time, especially on a big commercial job where it holds a lot of water, a lot of high water content, as the water starts filling up here, we put a hose on this and we open this, and that allows any debris that might float up in here to be flushed out before it can get into the system or get up into the air mechanism here. So it also allows you to get the air out much quicker. If we had just this little cap on the top that was allowing all of the air out of the system as we filled it up, it's going to take a while to come out of that cap. if we've got a full port half-inch valve here, we're going to evacuate the air much quicker. We're going to fill the system up quicker. So it's little features like that that we try and make it, you know, user-friendly and offer better, you know, a better solution to the whole process there. What you'll see out there is more and more wall-hung boilers that are coming on the market, and they typically have their piping out the top or the bottom. So we do offer this in a vertical version here. So instead of coming out and making a turn and going through the device, if you want to put it up at this point here, close to the hottest point, you can choose the vertical version of that. It's going to have the same performance, the same media inside that the water goes through. An example of our two, again, autofill combo over here with the backflow on it and the high flow here. A nice point to put that in the system is right at the point of no pressure change where the expansion tank ties into the piping. That's a good place to put your fill valve. This is a combination device that does both dirt and air. We'll talk about that a little bit more and some of the advantages of that. This here is another vent that we offer, and this is a little float vent, and this vent is intended to be used at high points in the system. You wouldn't just screw this into a T right next to the outlet of the boiler and expect it to do a good job of air removal, because there's really nothing to coax the air up into the chamber where it can be removed. So this we'll see a lot of boilers. You'll see this right on the heat exchanger inside or outside the boiler. It's going to catch air that just rises up to that high point in the heat exchanger. You might see it up on an air handler up in the high point in the building in the ceiling, or if you've got a couple riser pipes going up through the building, that's where this type of air elimination device would be applied. We do offer this, and a lot of people don't know this. This little adapter screws onto the thread on there, and it'll turn that into a 1/4-inch MPT thread, and then you can put, in this example here, a piece of 3/8 soft copper with a compression of FIP fitting screws onto that transition adapter, and now you can take this vent down to the floor or out of harm's way. If you have this up in the ceiling, you can route it out to where if this vent spits a little air or water sometime, it's not going to cause a problem. I think this shows some pictures of where that's where they use that air vent adapter up on the top there. All right, so dirt separation. So we can do a similar thing with dirt separation as we do with air separation. If we put a media inside there, we put a wide chamber in there. Again, we want to lower the velocity as we go through there, and we're going to put a media in here. And if you look at this, it kind of looks like an air separator that's been flipped upside down, and now instead of an air vent on the top of it, what we're doing is we're putting a chamber down here that will collect the debris that we're going to drive out as it goes through the media in here. So again, the coalescing media, fluid comes through there, but now we're not trapping our dirt and our deposits, whatever's in the system, in the fluid stream. We're driving that out. It's going to go to the bottom of this, and now we come back, we put a bucket or something onto this, open the valve, we can flush it out. I like to see what comes out of it so you know what's in your system. You might learn some things about what you have to do for treatment of that system. If you see a lot of rust and scale comes out of this thing, oh gosh, I better get back and do a better power purge on this system. This is the same concept over here, again, a larger steel version, welded steel version with flanges on it, rings, so if you want to hang that from some clevis hangers and some threaded rod, we make it easier for you to do that. A nice valve on the bottom so you can flush it out and get a good flow out of that. These valves on the bottom could also be used to inject chemicals into the system if you do need to put a cleaner in there and clean up the system, or if you want to put an inhibitor in your system, water can go into that as well as it comes out, so that is a nice point to douse it. We do give you this convenience port at the top. Some guys like to put a pressure gauge on there. Again, you could put a valve on that and use that for injecting chemicals into the system also. These are available with a insulated jacket on it. Makes it nice to clean it up for insulation. This is something that's starting to become a concern in systems, and this is a pump that you can see what we've done here is we pulled the rotor can off the outside of the rotor, and you can see there's some buildup on the outside of it. This is a strong magnet in here. This is an ECM type of pump, and you can see some deposits have collected and stuck to that magnet there. Well, what that's going to do is going to cause problems with the rotation of this pump, and that's in fact what happened with this is we were getting an error code that said the rotation of the pump was being impeded, and when we took it apart, we found that we had a bunch of fine magnetic particles that were stuck to this, and it was kind of jamming up that rotor, being able to spin side there. So this is a little bit harder, a little bit trickier to get out of a system. It's hard to filter this out with a media because it's a very fine particle. It's almost like if you took just a carpenter's pencil or a lead pencil and sharpened it with your knife on your workbench or on your table. that's the type of deposit we're talking about. Really fine. Sometimes they'll have a greasy feel to it, you know, picking up what's inside the system. But what you can do is exactly what's happening in this picture is you can attract it to a magnet. So if we put a magnet on a device in the system, we're going to try and, you know, collect that stuff before it gets into harm's way there. Worst case scenario, if you get a lot of that, it's going to settle to the low points in the system. Here's a boiler that was taken out of a job that had, in fact, the entire system had started sludging up. And when he took the boiler apart, that's what was in there. If you take that debris out and stick a magnet to it, if it sticks to a magnet, this is what you've got going on in there. And that's typically going to be caused by oxygen getting into the system. That's what can develop this condition. And if you've got oxygen getting into it, obviously you need to address that. That could be through a non-barrier tubing or something like that. So as we started identifying a need for a product, we started looking at, okay, how are we going to accomplish this? What's the best way to get those particles out and use some of the products that we've always got developed? So in some cases, it was just a matter of machining a little different component for the bottom of the dirt separator here and putting a magnetic band on there. So as the fluid comes through there, we've got the coalescing medium there driving out the big particles. This magnet is going to attract those smaller magnetite type of particles. They're going to stick to this band. You'll go back a year, months later, or something like that. Remove the band. I like to turn the pump off, remove the band, and flush out through the valve here and see what comes out of your system. Now keep in mind, you want to turn your fill valve on and make sure that as you're flushing water out, you're putting water in behind it, or you're going to end up with an airlock possibly in your system, or at least some air noise or problems in there. So whatever you take out of this these dirt separation devices, you got to replace with your fill valve or with your fill system somehow. So then we had the challenge of saying, well, what are we going to do on our welded steel vessels? We just can't put a magnetic band around the outside of that. The whole thing will turn into a magnet. That wouldn't work so well. So the solution that we came up with here is we said, well, let's put a dry well in there, a brass dry well in there, and let's put the magnets up inside that dry well. So the nice thing about this is now you can remove those magnets. You're not going to lose any fluid out of the system. Pull the magnets out, allow the debris to settle to the bottom, and flush it out on the bottom here just as you do with this one. Knowing that sometimes this dirt separator will be put on the return side of a piping circuit, maybe it's close to the bottom of the boiler, it might be close to the the floor. How are you going to get a long magnet out of that? So we segmented the magnets here, so as you pull this out, you can actually tip these apart, and then same thing when you put them back in. So they kind of bend, so to speak, so as you put this in there, you just go with segments click together and you push it in there. So that's the way that we're able to get a very strong magnetic device up inside a steel vessel and do a good job. We do, I think it might be a video on our website now, Mark, of a job that we did near the Chicago area that put one of these in. He's gone back to it, I think, 3 or 4 times now, and he's taken videos every time he's gone back of what he's flushing out of this old, it was an old iron pipe system that he did a retrofit with some new boilers in there and put one of these magnetic separators in there, and he's documented what it's doing, how it's working for us, and that was great. That was a nice thing to have, and we went down and took some pictures also of how well that system works. So the combination devices. So now what we thought we'd do here is offer a device that can do both those things in one component. So instead of buying 2 different components, you just put it all in one box, so to speak. So you can see in the picture here, what we did there is just we had the air separator and put the dirt separation portion on the bottom. It's a taller component here. We offer those in the smaller steel versions. We offer them also with the magnet on them. So now you've got the dirt separation, you've got the air separation, you've got the magnetic separation. Same thing in the steel version here. One question that comes up when we present this to somebody or they consider using it, they say, well, where should I put it in my piping system? You told me that I want to get my air at the hottest point in the system, which is, right at the coming out of the boiler, on the supply coming out of the boiler. That's true. And we want to catch the dirt before it gets into our boiler, into our pump, into our system. This would really be well used at the return on it. So yeah, it is a bit of a toss-up there. I don't have an exact answer for that. My suggestion would be it would maybe depend on the type of system. If you got a brand new system, it's all brand new copper pipe, new PEX tubing. You don't have a lot of rust and scale and debris from, say, maybe an old iron pipe or a cast iron radiator system. I'd like the air removal is probably most important to me. I'd probably put it up at the top on the hottest point in the system. Maybe if the system is an old iron pipe system and you're concerned with the flaking, the scaling being ongoing, I could put this down at the return. I can get air out of my system at the return. I'm going to do a better job at the top, at the hottest point, but I can also get a return. And the same thing with the dirt. I just would rather catch the dirt before it takes a trip or 2 through the boiler, through the heat exchanger. So that's what you're going to have to decide, is look at the job and just decide if this is right for you. If not, we do have the separate two components that you can use and put them both in the best places in the system. Probably one of my all-time favorites. This is something that I think Caleffi's really gone to bat and stepped up and come up with something that's very unique in the industry. This is what we call a Sep Forward. It's a hydraulic separator that separates different flows, the A-B side, kind of primary, secondary in a box, if you will. Over the years, we've evolved this product to where it becomes an excellent air separation device. We can put the same type of coalescing media inside there to do an excellent job of air removal. We can do the same thing at the bottom and do excellent dirt removal. We've added the magnetic band to it. So now we call this a 4-in-1 device: hydraulic separation, air removal, dirt removal, and magnetic separation. I'd even throw out there that could be called a 5-in-1 device, because we also give you this little port right here, and you can put a sensor well in there, and you could use that as the operating point where the sensor from your boiler goes. So now your boiler is looking at this separator, this device, this vessel, this capacity, this amount of water in the system, plus all the piping between the boiler over here and the device. Now that's the load that the boiler sees. So every time the boiler kicks on, it's seeing this whole content in there. So a lot of guys like to put their sensor in there and use that as the operating point. Most of the new boilers out there will have a it's a 6-millimeter diameter sensor that comes with them as an option. If you do want to, move it out of the boiler and put it somewhere else, we do have a well that accommodates that 6-millimeter that will go right into that port. So maybe we should change that to a 5-in-1. The dirt separation itself does an excellent job. Now, we're saying down to a 5-micron size that we can filter out here as we go through that media. Now, bear in mind, it'll take multiple passes to get those smallest particles out. It doesn't get everything the very first time like you might expect with a cartridge type of filter where everything goes through it, everything is trapped by the size of the filter. This does take a few passages through there. I think on our website we show the performance, and in the data sheet that comes with it, we show the performance typically at 20 and 50 passages through there, that we're going to get down to that very small micron particle pulled out of the fluid stream. Another product that we offer is a product that we call the ThermalCon. And what we did is we said, well, some guys like to add a little bit of capacity to their system if they've got a job where the boilers have the potential to short cycle due to micro loads that are presented to them. Why don't we just make a well-insulated tank that could go into the system and that could serve multiple functions? This could be a hydraulic separator, as it does have the connections very similar to the separator across the tank here. It becomes a well-insulated vessel for storing heat energy in. It becomes an air separator because up here we have a dome top. As we go through this, we're going to drop the velocity in this big chamber. That's a great place for air to be removed out of it. The same thing happens at the bottom. We've got a dome section here with a, this one here a little bit better, a drain valve there. So now that becomes a dirt separation device, an air separation device, a hydraulic separation device, and a storage vessel. So again, that can help you match your system to your heat emitters. If you've got a lot of small zones that were causing the burners to cycle on and off frequently, we're just going to add a little bit of volume, a little bit of capacity to the system. We made this stubby version. This guy said, gosh, it'd be nice if we have a tight mechanical space where we've got to get this and the boiler in the same space. Mount the boiler up above this, mount the tank below it, and now in a footprint probably less than 2.5 to 3 feet wide, you've got both your buffer tank and your boiler mounted in one spot. The key to that, a couple of things that were key to that, let me see if I've got another picture of it, is that we had large openings because we want to be able to handle high flow rates through this. With 2-inch openings here, we could handle, 40 GPM through this tank here. We wanted to give you a lot of options. So in this job here up in that Nathan did in Alaska, you can see he's put it in the corner, and by having the 7 connections around the tank on 3 different sides, now you've got the ability to go on one side and come out the opposite side, or come out the front here, or use multiple connections there. And Nathan's doing exactly what I just mentioned here. He's got a job where he's got a bunch of micro loads in the building, so he's connected his boiler directly to the buffer tank. You can put the sensor from the boiler into the buffer tank now, so the boiler's reference this as its load. It's going to heat up this tank. You can see he's put a variable speed ECM circulator that ties into the boiler output here, so that pump is going to modulate with the modulation rate of the burner to make sure you're getting just the right amount of flow through that. And now we're going to store that energy in here, and then we're going to just off to the right here, we're going to sip off the amount of energy that the load needs to it. So this is a really unique product in that we designed it specifically for that. It's It's not just a tank like you would buy off the shelf at a supplier. It's a tank that's been engineered to do all these things and do them properly, give you nice piping options here. We do have adapters for that. If you want to put a sensor well in there, we've got bushings that will accommodate the that same sensor well I talked about for the hydro separator. It'll take you down to that 6 millimeter, or if you have a different size sensor, you can bush into that. It's a glass-coated tank, and the reason for that is that, well, let's make it so if somebody wants to use it for domestic water storage, it can be a multiple-purpose tank. So we went with a glass-lined tank. You can put 2 anode rods in it. There's tappings at the top that you can drop a couple anode rods in there to make sure that you get a good life cycle out of that tank by having the 2 sacrificial anode rods dropped into that. It's got a nice coated jacket and stuff like that. So take a look at that. We do offer that in the small stubby versions and all the way up to 120 gallon. We've got a 50, 80, and 120 version of this tank available. They all have the large connections and ports to them. Let me take a look and see where I'm at here. I might need to pick up the pace. Here's a job thanks to Stephen Minnick in the Chicago area. I think probably one of the nicest piping you've ever seen. You can see here he's put together a few of our components. You can see the hydro separator there. You can see the fill valve. Sometimes guys put an additional air removal device on this. So here he's got air removal on the hydro separator. So maybe for the boiler side of this, he's saying, well, that's going to handle my boiler side, make sure I get my air removal quick and efficiently. But I also, since I'm going through so many different zones and stuff like that, I'd like to have an additional air separator up on the going out to my distribution here. So after it comes out of the separator up through the distribution, so he's adding additional. No harm in that. Would love to sell you 2 components instead of 1. So there are places where this is a good application to have the 2 separators working together. Some of our zone valves in here for zoning the systems. I don't know if we're going to get to that in this presentation today. Think big with Caleffi. We've been showing you, versions of separation for dirt and air and hydraulic separation. We do have large commercial size for that. We try and keep these. We do keep these in stock in Milwaukee. So if you don't have these on the shelf, we can get them out fairly quickly to you. We do have them in ASME listed devices if that's required on your job, as well as the CRN number for Canadian installations, Canadian regional number. All right, some of the other components now, we're going to kind of morph over. Let me see, I think I put that picture in here again. So now what we're going to do is we're going to leave this section here where we handled our boiler and our dirt and our air and our buffer tank for some storage. And now we want to start getting out into the distribution a little bit and take a look at some of the components that we offer there. So what we have to do now is we've got to pump the fluid around through the circuit. We might have to mix different temperatures or multiple temperatures. We might have a job where we've got to have zoning, where we want to turn different circuits or different areas of the building on and off. And we want to balance the system. We want to make sure that every zone in the building or every heat emitter in the building has just the right amount of flow that it needs to do the job, and that's where a balancing component would come into it. So pump stations. So we've got the ability to offer mix stations that can either go on our HydroLink, which I'll show you here in a minute, pipes right onto it. If you want to pipe into this from a primary loop, or if you want to have this built right onto a manifold, we can offer this solution here too, where now we've got the mixing right at the manifold, we've got the pumping right at the manifold, we've got the gauges, we've got the flow or balancing devices built right on the manifold. So this comes out of the box, you supply your temperature to it from your heat source, your boiler, you've got the mixing, you got the pumping, you got the balancing, and you've got the zoning down here. We take these caps off, we put actuators on. So this becomes a device that can solve all those functions right out of the box for you. If you want to build your own version of this, we sell the individual component here. Notice that we offer this with the high efficiency ECM type of pump, which is perfect for this application. If we're going to start adding zone actuators on this, this pump now has the ability to regulate its output based on what these valve actuators are doing as they open and close. We're going to change the speed of that, or the fixed speed pump we're showing here, thermostatic valve here, supply and return, blue and red to note the supply and return, and temperature gauges so you can see what kind of a delta T that you have going through that system there. This is probably one of my all-time favorite products, what we call the HydroLink. And so what we did here is we've taken the hydro separator function and we've just kind of evolved it to where we can have the hydraulic separation in the end chamber here. There's our 2 pipes coming from our heat source. Hydraulic separation here, closely spaced T's if you think of it that way. But also let's put the distribution piping in the same box. So now all we do is we make our connection to the boiler, our heat source here, heat pump, whatever it might be. And now we've got our our zone pumping that can go right onto that. Now you could have a fixed temperature going on of that. You could have a one with thermostatic. We offer it with a motorized mixing valve on it. So now you've got the ability, if you do have a system that requires different temperatures, high temperatures, low temperature, mid temperatures, we can do that right on this distribution box. So no piping in the boiler room, just come from the boiler to the device, put your pumps on, and go right out to wherever your heat emitters are there. So it's a really simple solution to not only make sure that you get the proper flow rate with the the separation function here, but also that you've got the ability to mix and match different flow rates, different pumping stations, different flow requirements out at the distribution side. Whoops, sorry. Manifolds by themselves. This is probably the most common for PEX loops out to radiance system. We've got the we can adjust the flow rate here. We can put actuators on it. We've got air removal here. We've got connections to fill and purge if you want to do it at the valve, isolation, temperature gauges. High flow versions of that, maybe for snow mount applications, or higher flow, maybe out to some air handlers or something like that. We do have this with the, as you can see, the bigger manifolds, higher flow rates. Here's an example where I said we can build this. If you let us know what you want, we'll build this mixing station on it. The PEX fitting that we offer is kind of unique in that it's a universal fitting. It fits a lot of different PEXs. We've got a tapered, both on the inside and outside of that fitting. So if the eye to your tube is a little bit off, we can compensate that with the Doba O-rings and the taper that's built into the insert that goes into the fitting, and a nice fitting that goes up into the manifold that we get a seal on that nose with an O-ring. We do have a wrench for that. If you're not aware of that, that's kind of nice. So when you have these connections that are real close to one another, tough to get a channel locks or wrench in there. Nice to use the box wrench. That isn't, number one, going to mark up your fittings or tear up the brass as you put it in there, and allows you to get in there. You can see it split open at the end, so you can slip it over the PEX tubing, put it up there, and tighten it up. So we make it real convenient and easy for you to do that. Zoning options, we've got a couple different options there. This is what we call our Z1. This valve is now available with press fittings on it. It's available in sweat. It's available in threaded. It's available in flare fitting. It's also available as a three-way mixing valve. I would say this, what we call a spring return valve, powers open spring returns, is the workhorse in our industry. It's probably the most common valve you see out there. In some cases, people want a slower action valve. This is a thermo-actuated zone valve here. And over here, we've got basically a ball valve with a motor, motorized ball valve, high flow rates there, high shut-off pressure. Different applications for these valves. It just depends on what type of flow rate you're trying to shut off, what you're expecting the system to do. But I think we've got a solution for probably pretty much any zoning application you might have. And again, some more nice pictures that were sent into us over the years in our excellence program there, showing how these zones have been added to systems. The zone valves have been added to systems. Balancing valves, this in itself is a one-hour webinar, but this is a quick overview of what we offer. We've got manual balancing valves, what we call our 132 quick setters. The 132 plus, the plus meaning that that's for domestic water, so we've added, it's a low lead version of that, or lead-free, we call it. Usually low lead is indicated by LF. It can be used on domestic water. It comes with a gauge on it, a temperature gauge on it, so you can balance domestic water recirc loops by temperature. This is a variable orifice valve, also a low lead version, because that can sometimes be used in domestic water applications. Here's a 130. This is a fixed orifice valve, PT ports on these valves, so you can put a differential pressure gauge on that and adjust or confirm the settings on that. These are auto flow valves here. This has a little cartridge or spool in there that moves back and forth based on the pressure change in the system. This is another version of that valve there. This one here, you can get the cartridge out and remove it. This one here you buy, you tell us what you need for a flow rate. We'll build that and send it out to you, label it. This one gives you the ability to change the cartridge in the field. We'll give you a tag that tells what's in there, how it was built. If you change the cartridge, it will come with a new tag. It does have the ports to confirm that you do have the flow rate that you're expecting through that device. So pressure independent valve is what the PIV stands for. A little better shot of that Quick Setter Plus I was telling you about, and kind of an example where it might be used in a system. If I'm trying to balance multiple domestic hot water loops, I know that I need a certain flow rate to these different loops. I could use this valve and dial it in. If I don't know a flow rate, I don't have the design criteria, I could just use the temperature gauge on that, because really all I want to do with that recirc is overcome the temperature drop going through this piping circuit here. So if I'm going out at, let's say, 120 degrees out of the tank, I want to have about a 10-degree temperature drop, make sure that the last fixture on the line gets a reasonable temperature. I can just adjust that by the temperature gauge. So it's really nice for that. All right, now we got to keep it all working. I showed you, again, a quick view of some of the products here. We'll get to some more next month. You got to be concerned about what you're putting in these valves. You know, we send the valves out with nice, clean, shiny brass inside of them. When we see a picture like that, we're concerned. You know, what's going through that valve? That's going to cause problems, can cause problems in there with the flow regulation. Worst case scenario, we can actually close that opening right up and have a problem. So we need to know what's in our water when we fill them. We need to know that if we've got a system, we might need to put a cleaner in there and flush it out and stuff like that. Fluid quality, that's again what we'll be talking about on our next Hydronics issue, number 18. We will have a webinar on that early next year in 2016 also. Valves in the appropriate location so that when you do have to service a zone valve or something like that, you've got isolation close enough to it. Explain that to your customer, to the homeowner, to the building owner, what's required to maintain a valve. If you've got valves in domestic water systems, if you've got hard water, they're going to have to go in there occasionally and descale that valve. Thermostatic mixing of valve is a classic example of that. You know, help them put together a program. Say, you know, I'll come back every 6 months. I'll check your valves, make sure that everything's working properly. So just don't assume that it's in there and it just stays there forever. It's going to work fine. Support, we've got all sorts of support for you. Suppliers, we'd like to think all the suppliers know everything about all our components, can help you right at the counter where you buy your components. We realize that, you know, they've got a lot of products, a lot of things to learn and know. So if you can't get the support or the help you need from them, we have reps. If you go to our website, we've got a rep locator that can put you in contact with them via email or phone number, something like that. That would be the next source of information. You can call us. We've got Kevin, we've got Cody. Pretty much everybody at Caleffi Milwaukee can help you with a technical support question or get you the information you need. We all have cell phones. I'll answer and help you if I'm out in the field and get to a phone. So whatever we need to do to support you, just get a hold of us and let us know that you need help with a design or with selection or something like that. Hydronics, there's a good support mechanism right there. We have in the back of all the Hydronics a lot of product information, spec sheets and stuff, so if you're trying to size something, you can sometimes find that in the Hydronics, and of course those are available as a PDF online also. The Coffee with Caleffis that we're doing today are archived on our website, so if you want to pull one up and look at it, if you're going out to do a job and you want to just pull up that topic and get up to speed a little bit on it, go to our archive there and pull it up and take a look. If you aren't getting these or you were getting them and they stopped coming for some reason, go to our website and register again and make sure that you don't miss an issue of that. Keep up to date with us, all these different social media formats that we're on. We've got Ask Caleffi, we tweet, we're on Facebook, we're on YouTube. We'll get to you somehow, or you can get to us somehow. Well, any questions there, Mark? I didn't have a chance to monitor them as we went along, but I'll certainly try and answer a couple here in the last couple minutes, and then.
Yeah, sure. We have a couple that would. I don't know if you can get back to your slides, but the schematics of the near boiler piping. In one schematic, it showed the pump pumping away from the boiler. On another schematic, showing the pump pumping into the boiler. Why would one want to pump away from the boiler versus pumping in, and vice versa?
Well, as far as pumping into a boiler, a lot of the new ModCon boilers that have tight heat exchangers, the manufacturers suggesting that you pump into it so that the boiler sees that increase in the delta P when the pump starts up. So what we want to do is pump away from the point of no pressure change, if at all possible. The point of no pressure change is where we connect the expansion tank in the system. So in this picture here, you can see we've attached the expansion tank. We've established our point of no pressure change right here. So this vessel, being a big wide open space, is a continuation of that point of no pressure change. So this pump here, being that this whole area here, so to speak, is the point of no pressure change, is pumping away from the point of no pressure change, and it's delta P into the boiler here, because that's what we're doing, is pumping right into the boiler here. And the same thing over here. This, even though it looks like it is on the red line, it looks like it's a supply line, we are still pumping away from this point of no pressure change. So, you know, as you add more and more pumps here and you get further out in the system, you know, you're getting further away from this point of no pressure change. We can't have that exactly right at the suction side of every pump in the system as we start going out to remote manifolds that have pumps out here, or we've got a HydroLink a distance apart. But that's the key, is we want to pump away from that point of no pressure change as the expansion tank connection as possible, as close as possible to that. And that's what we're showing here. in this here, of course, the tank is quite a ways away. We got the tank here for the hydraulic separation buffer tank. This one over here. We want this to do the same thing, pump into the boiler here on the return side. So that would be a little bit different. It's a little bit further away from it, but that's your goal, is to try and get everything pumping away from that point and no pressure change. I think I got that.
Thank you. Another question concerning hardware around the boiler. Low water cutoffs. Are they needed? Are they built into the boiler?
Yeah, excellent question, and I would say yes and yes. I mean, they are needed, and most of the boilers are going to require that you have one on. It's protecting the boiler, so if you have a water leaks out of the boiler, you have a problem or something like that, we want to shut that fire off before we cause damage. What I see a trend towards is pressure switches in some of these boilers. So instead of using the flow switch, which we offer here, this is a paddle type of flow switch, and that's going to detect, flow going through it. And if there's no flow, it interrupts the signal to the pump or to the boiler, to all the equipment in here, and it shuts it off. Another way of doing that is have a switch, in which you'll see in a lot of these boilers, they'll have a pressure switch right up here on the boiler, and that's going to tell you that if the pressure drops in the system, it's going to drop the burner off. That doesn't necessarily protect the rest of the components in the system. By using a flow switch like that, or you can use them, you could have both of them in there. What this could do is you could wire everything in this drawing through that flow switch. So if you want the pumps to shut off when there's a low flow condition, it can drop off the signal to the boiler, the power to the boiler, as well as shutting off the pumps. Where the pressure switches in the boiler sometimes will only shut off the burner, and you can still have a problem if you're running pumps and you've developed a leak and leaked the fluid out of it. I want to thank everybody for attending today, and we'll see you again in a month, and have a good day.